Alright, today we're going to be talking about geometric sequences in series, okay? Let's start with the definition of what a geometric sequence is. A sequence is geometric if there is a ratio of consecutive terms and it happens to be the same. Elements A1, A2, A3, A4, so on until you get A's of n. Is geometric if there is a number R such that if you were to take the second element and divide it by the first element, you get the same ratio as if you were to take the third and divide it by the second, or as if you were to take the fourth and divide it by the third. In other words, it's going to be the same rate throughout. The rate cannot be zero. And so the number R is the common ratio of the sequence. To find the nth term of a geometric sequence, you can use the following formula. A's of n equals A's of 1 times the rate raised to the n minus 1 power. You have to memorize this for the test. Alright, let's make sure we all understand what this means. A's of 1 is your first term. R stands for the rate. I hope you know that n stands for whatever term we're talking about, correct? Alright, so we'll start with something easy. It says, let's find the common ratio between 3, for the following sequence, 3, 9, 27, 81, 243, and so on. Okay. I think most of you guys can see that the ratio here without really doing much is that the ratio is 3, because you're multiplying by 3 every time. However, if you wanted to use the formula which is up here, which again you would have to memorize if you want to do it, it says to simply take the second term, so it's 9, and divide it by the first one. So 9 divided by 3 is 3. If you were to take the third term, 27, and divide it by 9, you will get 3. And if you were to do the same thing over and over again, you will then realize that the rate does happen to be 3 throughout the entire sequence. Okay? Alright, number 2, find the 15th term of a geometric sequence whose first term is 20 and whose common ratio is 1.05. So if you memorize the formula, which you will, remember that is A's of n equals to the very first term times the rate raised to the n minus 1. In your problem, your first term happens to be 20 and your rate is 1.05. So if you're trying to find the 15th term, it's going to be A's of 15 equals A's of 1, which is 20, times your rate, which happens to be 1.05, raised to the 19th power. Now, if I gave you such a problem, you will probably see it on the calculator. I don't expect you to know what 1.05 to the 19th power is off the top of your head. Okay? So, oh, I'm sorry, it's the 15th term. I'm sorry, my mistake. Yes, it's the 15th term, so my mistake. So it is 15 minus 1, so it will be the 14th power. My apologies. So if you plug into your calculator 20 times 1.05 raised to the 14th power, you get 39.599. And that will be your 15th term. Not too bad, right? Alright, try number 3 and number 4, please. Alright, take a moment to check your answers. Pause the video as needed. Any questions over number 3 or number 4, guys? We're good? Alright, so let's flip the page. Let's go to number 5. Number 5, I think you can try on your own as well. So just for the sake of the video, you can try that one on your own. I'll show you the answer here in just a second. Let's move on to problem number 6 together. Okay. Number 6 changes things a little bit. You are told that the fourth term, so in this case A's of 4, is 125. And you are told that the 10th term, so A's of 10, is 125 over 64. They want you to find the 14th term if all the terms are positive. Any suggestions of what I can do here? because I need to find the rate. Do you guys agree? So if I can find the rate, I'm able to find out the 14th term. Not quite. Let's think about this one. Here's what I'm going to set up. So I know that the fourth term is 125, right? And then you're going to have a fifth, sixth, seventh, eighth, ninth, and then your 10th term is going to be 125 over 64. You guys agree? All right. Well, remember that geometric sequences work in a way that you take the number and you multiply by a ratio, the same ratio every time, right? So you would, once you have your ratio, you're going to say 125 times that ratio, and it's going to give you this term. And then you're going to take that term and multiply by the same ratio to get that one, correct? And so on until you get to this term. So times the same ratio over and over again. You guys agree? Couldn't I, correct me if I'm wrong, couldn't I take this times 1, 2, 3, ratio times ratio times ratio times ratio times ratio times ratio? Wouldn't that be ratio to the 6th power? Right? Because 1, 2, 3, 4, 5, 6. Couldn't I say this? Wouldn't that be true? Do you guys agree? Cool. Now, if I wanted to solve for r, in this case, I'm going to divide by 125 on both sides. Do you guys agree? So it's going to be r to the 6th power equals 1 over 64. Now, from here, suggestions. I mean, you can do this mentally. How do you know it's going to be 1/2? First of all, can we all agree that it has to be a fraction? Okay? Now, here you're going to have to depend on how well you know your powers. Okay? 2 to the 6th power is 64. So if you know that, but you know that you have to have a fraction, then you can then assume that it has to be 1/2 because your numerator happens to be 1. Correct? So, okay, my rate is 1/2. Now that I have my rate, what can you do to find out the 14th term? There's a couple paths that you can take here. You can either go back and try to find the equation to find any term, or let me ask you something. If you were going to find the 14th term, right? This is the 10th, 11, 12, 13, 14. That's what we're looking for, correct? Couldn't I take this number and do the same process? Times r, times r, times r, times r. So that'll be r to the 4th power. But in your case, you already have the r. Do you guys agree? So you could say 125 over 64 times, well, what's your rate in this case? 1/2 to the 4th power. That's going to give you your 14th term. Do you guys agree? Now, do you have to go in this direction? You don't. If you want to find the equation that can give you the nth term, by all means, go in that direction. And I can show you that here in just a second. So if we were to solve this, wouldn't that be 125 over 64 times 1 to the what power? 1 over what? I'm sorry. 2 to the 4th power is 16. Correct? So 125, I don't know what 16 times 64 is, honestly. And that would be your 14th term. Now, if you want to go in the other direction, once you find your rate, couldn't you go back to a sub n, right? You know that it is the first term times the rate raised to the n minus 1, correct? Now, in order for us to figure this out, we need to find our first term. Do you guys agree? In order for us to have that. Any suggestions of then how I can do this to find the very first term? Right, so you could take, for example, you have the 4th term, correct? Do you guys agree? The 4th term is 125, so we can say 125 equals the first term times your rate. In this case, your rate was 1/2. Raised to the n minus 1. Well, when it's 125, isn't your n the 4, right? So 4 minus 1 will be 3, correct? So then it would be 125 equals a to the first. Well, 1/2 to the 3rd power would be 1 over 8, correct? Which means that to get your first term, you would have to divide 125 by an 8th. So 125 divided by 1/8. And you get that your very first term happens to be 1,000. And I believe that now that you know the first term and your rate, you should be able to then come up with the equation, which in this case would be a sub n equals 1000 times 1/2 to the n minus 1. And then you can use that equation right there to help you figure that out. Again, multiple paths to get to the correct answer. I don't care which one you choose, as long as you show me some work. If I don't know how you got from one step to the other, I might take some points off because I wouldn't know how you got there. Cool? Can you then try number 7? Okay, so go back and finish 5 and number 7. Pause the video and check your answers. Alright, check your answers. Here's the answer for number 5. And number 7. Any questions on those, guys? We're good? Alright, so let's go ahead and move on to the next. And now we're going to talk about actual series, okay? Okay, this is a formula that you're going to have to memorize as well. To find the sum of a finite geometric sequence, you're going to use the following formula. The sum of a finite geometric sequence with a common ratio, where the ratio cannot be 1, is given by the following formula. The sum of a geometric series equals to the first term times 1 minus the rate to the nth power all over 1 minus the rate. Now, I want you to pay close attention to how this looks. Isn't this right here, this part right here, I'm sorry, from here to there, that represents a geometric sequence. Do we agree? Because you have the A1, a sub 1, the very first term, the rate, and then you technically have, instead of an I, you can just put an n, right? N minus 1. That's the exact same formula that we had on the first page, correct? You need to keep that in mind because it needs to be exactly the same when you're applying this. Look at number 8. Is this the exact same thing as that? Number 8. It's not. Why? Why is it different? It's minus 3. Be careful. My advice to you is don't just assume that your first term is going to be 4, because this looks very similar to a geometric sequence. Do you guys agree? And typically that number is your first term. Don't make that mistake on the test. I suggest just go ahead and find your first term. Plug in this case, if you're finding your first term for this, you're going to have to actually plug in 1. Do you guys agree? So that would be 4 times 0.3 raised to the 1 minus 3, which in this case would be 4 times 0.3 raised to the negative 2. Correct? Now, if you plug that in your calculator, 4 times 0.3 raised to the negative 2 power, you get, I'm going to turn it as a fraction, 400 over 9. Now, do you see how 400 over 9 is definitely not 4? If you were to plug in 4, you would get this problem wrong. Okay? Now that you know your first term, it says that you need to know your rate. Well, in this, your rate is going to be actually how it looks in there. This is your rate, the 0.3. Okay, so your rate is 0.3. So now you are ready to apply your information into the formula. It says that the sum, in this case we have the sum from the first term to the 12th term of 4 times 0.3 raised to the I minus 3 would be, in this case, your first term, which is 400 over 9, times 1 minus your rate, which in this case is 0.3, raised to the nth power, which in this case will happen to be 12, all over 1 minus 0.3. Correct? Now, at this point, again, you can expect this on the calculator part of your test. Just input into the calculator as it is. So, 400 over 9 times 1 minus 0.3 to the 12th power, all over 1 minus 0.3. And you get approximately 63.492. Cool? Now, I am aware that I'm going to give you this on the calculator part of your test. I'm going to give you instructions that are going to say you must use the formula. Because I am aware that your calculators that you possess have that shortcut where you actually can input this symbol and you can input anything. Do you guys remember how to do that, or do you want me to show you how to do that? Can I borrow one of your calculators because mine is different? Real quick. Alright. Your calculators that you have, nice fancy calculators, are actually capable of performing all this without you having to memorize the formula. So what I would do, again, I'm going to say in the instructions, you have to use the formula, but you can check your work to make sure that you did it right. For example, if you would have made the mistake of using 4, then you would find out that you did the wrong thing. But here's how you can input the problem just as it looks on the calculator. If you hit, I believe it's alpha window, option number 2 says summation, hit enter, and it gives you those symbols. And all you're going to do is plug in what you know. Well, you just switch the variable from I to x, so x is 1, and goes to 12, and type in your actual expression. So 4 times 0.3, close your parentheses, raised to the x minus 3, hit enter, and we get that, which matches what we got over here, correct? Again, if you would have used the 4, you probably would have been like, wait, what? This would have told you, hey, I did this wrong. Go back and check your work. Cool? So again, this is just for you to be able to check your work. It's alpha window, option 2. Problem number 9. So pause the video and try it on your own. What's that? Yes, sir. Okay, so you have to memorize this one. Change my mind. Yes. The quiz is next class. Okay. All right. One more formula thrown at you. Okay. All right. This is the formula to find the sum of an infinite geometric series. Now, I think, Kunal, right? You shared this with us last time, right? So I went and did my research a little bit because we had a couple problems on the 9.2 notes where I was asking you for an infinite series. And the reason why I worked on those notes is because they happen to be geometric series, the ones that I gave you there. So I did my research, and this only works when you have geometric series. Okay, I couldn't find anything that said that this will work with arithmetic sequences, but I'll check again, or if you want to check. I don't think this. I think this should only work when you have an infinite geometric series. Okay, all right. Again, I want to bring your attention to exactly how it's written. Okay, because it's different than the geometric sequence. Look at how it's written. You still have your first term, you still have your rate, but notice that it's not longer raised to the n minus 1. It's just raised to the n, or in this case, the I. And also, notice that your first term is 0. Okay? Alright. So, let's try it out. Is this written the exact same way as that is? So then, can you assume that 4 is the very first term? No. Again, just to be on the safe side, it takes you about 10-20 seconds to actually find out what the first term is. If you were going to find out the first term, you would say the first term in this case would be 4 times 0.6 to the 0 power. Do you guys agree? Now for this one, it happened to be that the 4 did end up being our first term. Do you guys agree? Because anything to the 0 power would be 1. 4 times 1, 4. Cool? So now let's apply the formula. So the summation, in this case, it's the summation of the following infinite series n equals 1 of 4 times 0.6 n minus 1 equals the first term divided by 1 minus your rate. In this case, your rate is 0.6, correct? So this would be 4 over 0.4. Well, 4 divided by 4 is 1, but it's got a decimal, so I'm going to move it over, so it should be 10. Correct? I guess I'll give you a break on that. Okay. I know. Alright.
Doesn't the formula at top say I instead of I minus 1?
Yes. But I was just finding the summation of this one. So what I was saying is that don't just assume that whatever number here is your first term. That's what I was bringing your attention to. Actually find it out. But yeah, you are finding the summation of this. You don't have to manipulate this to make it match that. You just have to keep in mind that this doesn't automatically tell you that that's the first term. Actually find out. Because you have two options. You can either always check that it's the same thing and then assume, or if you don't want to check and you just want to find it first term every single time because it doesn't take that long, then just go ahead and do it every single time. Okay? Alright, next one. Okay, let me ask you something now, because I forgot to mention something that's very important on that, so you don't have to flip back, or if you want to. This formula right here, guys, it's only going to work if the absolute value of your rate is less than 1. And that's very important. This is only going to work if your rate, or the absolute value of your rate, is less than 1. Cool? So in other words, it has to be between, well, not 0. It's got to be greater than 0, but less than 1. Correct? Alright. Let's look at this. Suggestions of how I can figure this out. Because this is an infinite, right? But I don't actually have the sequence of it. Okay. Do you guys agree? I'm going to rewrite this. That this is the same thing as saying 3 plus 3 over 10 plus 3 over 100, right? Plus 3 over thousands, right? Because that's 3 tenths, right? 3 hundredths, 3 thousandths, correct? Suggestions. What do you think I should do? Can we actually find out what the equation for the sequence would be at? Can we? Alright, so we know that a sub, remember, to find a geometric sequence is a sub n equals what? First term, right, times the rate, raised to the n minus 1, correct? My question to you is, do you know the first term? Yes, you do. So a sub 1 is 3. Now my question is, do you know the rate? If your first term is 3, and then your second term is 3 tenths, and then your third term is 3 100ths, and then your fourth term, how are you going to figure this out? What's that? Times 0.1, I'm sorry? 0.1? Well, let's try it. If you do 0.1, let's try it. So if you do 3 times 0.1, then you get that, right? And then if you do times 0.1, then you get that. Correct? Is that the next term? Right? And then if you do times 0.1, then you get that. Is that the next term? So it is 0.1. Do you guys agree? So your rate is 0.1. Cool? Now, does anyone not know how we got the 0.1? Because yes, that's fine. So again, that's what I was going to. Remember, if you want to find your rate, you can take the second term, so 3 over 10, and divide it by 3, which in this case would be 3 over 10 times 1 over 3, correct? 1 over 3. Those cancel out, giving you 1/10, which is the same thing as 0.1, correct? Alright, so now, a sub n equals 3 times 0.1 to the n minus 1, correct? Now, if we actually want to find the summation, right, we're looking for the series. And this is an infinite series. This will be the summation. We're going to start at the first term, and we're going to go towards infinity. And it tells of the following, of 3 times 0.1 to the n minus 1. The formula tells us to do what? You can flip back if you need to. The first term, what's your first term? So 3 over what? 1 minus r, correct? So 1 minus 0.1. So wouldn't that be 3 over 0.9, correct? So 3 over 0.9, 3.33333, right? You guys agree? And if you turn that into a fraction, 10 thirds. So your answer is 10 thirds. I mean, I'm just showing all the work. That's all. Okay? Alright. I want to talk about number 12 together. Number 12. Your first term is 3. What's your rate? Okay. Because your rate, notice your rate is the absolute value of a rate less than 1. Is it? No. 2 is not less than 1. You can't use that formula. But let me ask you something. If you're adding 3 plus 6, plus 12, plus 24, plus 48, so on and so on, are you ever going to reach one specific number? No. You're going to go to what? When your rate is greater than 1, you're always going to reach infinity. Just infinity. Well, you can write all of this, okay? Alright, number 13. You guys want to try it on your own? Does it know what is do you guys know what it's asking you? Okay. First of all, do you guys understand that 0.39, what does that symbol mean? Repeating is the same thing as 0.393939. Do you guys agree? Couldn't I then write this, think about it this way, couldn't I say that the first term is 0.39? And can I say that my second term is 0.0039? And my third term is 0.000039. And so on. Do you guys agree? Because then if I were to add that, I would get the 0.3939393939. Can you apply what we did on this problem to there? Try it. Alright, so check your answer. The fractional representation of 0.39 repeating is 13 over 33. I'm sorry. Alright, last problem. You guys remember how on 9.2 I told you that they're going to word certain things similar to this? Find 3 geometric means between 5 and 80. Remember, that means that you have 5 and then you're going to have 3 other terms in between them. Okay? So, the key is here is that they're telling you that they're geometric. Correct? Suggestions. How can I do this? So wouldn't that be times r, times r, times r, times r? Correct? So couldn't I then say that 5 times r to the 4th power equals 80? Correct? So then you could say r to the 4th power, well, what's 80 divided by 5? 16. Now be very careful here. My question to you is, what is the 4th root of 16? Plus or minus 2, actually. It is 2. But negative 2 will also work, because negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is positive 16. So you're going to have two possible answers here. You could either have the following sequence. You could have 5, 10, 20, 40, 80. Or you can have 5, negative 10, 20, negative 40, 80. What was given to you from the beginning. Correct? Be careful. when you're doing this type of problem, don't forget to consider that when you take even roots, do you guys agree? Even roots, you have a positive or a negative. Cool? Alright, that's all I got for you today. Homework is on the hub.